Hello everyone, welcome to Engineering Archives. Let us look at practice problem number. So this problem says, express each force as a Cartesian vector. And the second part is, determine the magnitude and coordinate direction angles of the resultant force acting on the hook. So pretty much the same procedure as the previous practice problem. We have to express them as Cartesian vectors first, and then we have to add them, then find their resultant magnitude using the resultant force formula, and after that we have to find the three angles that they make with the xy, that the resultant force makes with the x, y, and z axes. So let's express F1 as a Cartesian vector first. Notice that the force F1 exists in the xz plane, which means it is only going to have components in the x and z directions. So to find its component along the x direction, we will do 300 cos of 30 degrees. And this is going to be equal to 250 newtons. While its component in the z direction is going to be equal to negative 300 sine of 30 degrees. And this is going to be negative 150 newtons. It's negative since it's directed in the z direction. So moving on to the force F2. So first of all, let's find its component along the x direction. That is going to be 500 cos of 45. So when we do cos of 45, we get the component in along this line. And when we do sine of 3, we get its component along this line, along the x-axis. And the value that we get for this is 176.8 newtons, but we can round this off to 177. Moving on to component along in the y direction, we do 300 cos of 45 to get this component in that direction, and then cos of 3 degrees to get the y component, which is equal to 306.1 newtons. Lastly, component along the z direction, we can simply do 500 sine 45 degrees, but notice that it's in the negative z direction, so there's going to be a negative sign, and this would give us negative 353.5, but we can round this off to negative 350. Now that we have all our components, we can write both forces in their Cartesian forms. So F1 is going to be 250 I minus 150k, while F2 is going to be 177 I plus 306.1k minus 354k. Adding both these forces, we get F resultant equal to 250 plus 177. I'm going to just skip to their sum, which is 427 plus 306.1k minus the sum of the k components, which is 504k. Negative 150, negative 354 gives negative 504k. Now that we have the Cartesian form of the resultant force, we can use this to find the resultant force's magnitude by using the resultant force formula, which is the sum of the squares of all components square root and the value that we get for the magnitude of the resultant force is 28 newtons. Now that we have the magnitude of our resultant force, we need to find the three coordinate angles. And in order to do that, we will use the formula that we have used in previous videos to find coordinate angles of different forces. And that formula is cos of an angle, say from the x-axis, is equal to the component of the force along the x-axis divided by the magnitude of the resultant force. So if you want to find theta x first, we will do cos of theta x is equal to component along the x direction, which is 427, divided by the magnitude of the resultant force, which is 728. Taking arc cos of both sides, we get theta x is equal to 54.1 degrees. Now solving for theta y in a similar fashion, we get component along the y direction, which is 306.1, divided by the resultant magnitude, and we get 65.1 degrees. And lastly, for theta z, negative 504 over 728, 135.8 degrees. So this was a simple and easy procedure for this question. Thank you very much. See you in the next video.